this video, we are going to learn about the subtopic 4.2, which is about functional groups and homologous series. The learning outcomes for this subtopic are A. Define functional group, B. State functional groups of the following class of compounds, C. Identify functional groups in a given compound, D. Define homologous series, E. Explain general characteristic of homologous series, which are the first one represented by a general formula, second, same functional group and chemical properties, third, gradual change in physical properties with increasing number of carbon atoms, and the last one is successive member of a series differs by CH2 group. Now, let's look at the definition of functional groups. Functional group is known as an atom or group of atoms in an organic molecule which characterize the molecule and determines how the molecule reacts. The importance of functional group are to classify organic compounds which are divided into different classes, to name the organic compounds, and a particular functional group will always undergo similar types of chemical reactions. The first class of compound is alkene. This is an example for alkene compound. For alkene compound, there is no functional group as this molecule only has carbon-carbon single bond. The next class of compound is alkene. This is an example of alkene compound. The functional group of alkene compound is carbon-carbon double bond, as we can see from the structure of the molecule. The next class of compound is alkyne. This is an example of alkyne compound. The functional group is carbon-carbon triple bond. The next class of compound is haloalkane. This is an example of haloalkane compound, and the functional group is halogen, which this halogen can be fluorine, chlorine, bromine, or iodine. The next class of compound is alcohol. This is an example of alcohol compound, and the functional group is known as hydroxy group. The next class of compound is phenol. This is an example of phenol compound, and the functional group is known as hydroxyl group. The next class of compound is carboxylic acid. This is an example of carboxylic acid compound. The functional group is known as carboxyl group. The next class of compound is ester. This is an example of ester compound. The functional group is known as carboalkoxy group. The next class of compound is anhydride. This is an example of anhydride compound. The functional group is known as anhydride. The next class of compound is ether. This is an example of ether compound. The functional group is known as alkoxy group. The next class of compound is aldehyde. This is an example of aldehyde compound, with the functional group is known as carbonyl group. The next class of compound is ketone. This is an example of ketone compound. The functional group of ketone is known as carbonyl group. The next class of compound is acyl chloride. This is an example of acyl chloride compound. The functional group is known as acyl chloride. The next class of compound is amide. This is an example of amide compound. The functional group is known as carboxamide. The next class of compound is amine. This is an example of amine compound, and the functional group is known as amino. The next class of compound is nitrile. This is an example of a nitrile compound, and the functional group is known as cyano. And the last class of compound is known as aromatic or arene. This is an example of aromatic or arene compound with the functional group is known as benzene ring or phenyl group. Now, let's look at the homologous series definition. Homologous series is a series of compounds which all contain the same functional group and each member differs from the next member by a constant of CH2 unit. Members of the same homologous series are called homologues. The characteristics of a homologous series are: the first one, it has a general formula where it applies to all compounds in the same series. For example, if we have an alkene compound, the general formula would be CnH2n plus 2. Second, the physical properties change gradually with increasing number of carbon atoms, such as it changed from gas into liquid and finally to solid. It also has similar chemical properties, same functional group and chemical properties, and the successive member of a series differs by a CH2 group.